Thank you very much. Good evening. God bless the day as usual. My name is Nasser Abdul Salam. Last week we had an introduction to the Arduino as requested by one of our follower. And the next on the list, as I promised, is the tracking system. That's the GSM GPS tracking system. So I quickly have the block diagram. As you know, we only have three acts: block diagram, circuit diagram, then the simulation. So going by the block diagram, now we're going to quickly look at things that we are going to need for our tracking system, be it a car tracker or a vehicle tracker or a device tracker. So the first thing there now is the power supply that is going to energize all the circuit system. So basically, based on this implementation, we are using lithium ion, normal lithium ion. You are going to connect three of them in series. When you connect three of them in series, each one is 3.7 volts, then 1200 milliamp. And when you connect 3.7 by 3, you're going to have 11.1 volts. So that's the voltage requirement. So essentially, you're going to connect this guy, three of this guy in series for you to be able to have that. Then coming here now, each of the components that build the circuit have their own requirement. Like this, the controller. You can decide to use either Arduino Uno, as we saw last week, or you can decide to use Nano or Mega. Anyone you choose is still fine. Or you can decide to use the microcontroller itself. That's the Atmega. You're going to remove it and use it as standalone. But based on this video, we are assuming you're going to use the Arduino board. So the Arduino board now can be powered anything from 5 volt to 12 volt, but I recommend 9 volts. So I always power it with what? With a 9 volt. Using a voltage regulator LM7809. Then coming to the GPS, as we know, we have different flavors for the GPS. We can have the Neo 6. This is Neo 6 GPS module. This guy will work fine. Or you can go with the unblock, that is the Neo 7. Neo 7 also works fine. It's also tracked very well. The Neo there means near Earth orbit. Or you can go with VKL, but I strongly recommend VKL. Though it's very expensive, but it's actually good. It's both in and outdoor, indoor and outdoor. You can easily track the GPS for you. Then coming down to the GSM module too, we have different flavors. What we have here is SIM 900. You can try to use SIM 900. SIM 900 work with 5 volt. Or you can use SIM 800L, which is more cheaper. And I recommend it. This is SIM 800L. You can go with it. It's more cheaper and it works fine. Or you can go with the SIM 900. That's the A6. This one too works fine. Though you can power this one. This one always power with 5 volt and use normal SIM, not micro SIM. Normal SIM, not micro SIM. While this SIM 800L here now, you have to get a micro SIM for you to work with it. And you can power the SIM 900 with 5 volt. AC is also with 5 volt, but anytime you are using SIM 800L, then you need a buck converter that will step down the voltage for you from the 11.1 volt to 4.2, 3.7 to 4.2 volt. So this is the buck converter here. You can see LM2596. It has both input and output. So you plug your battery output to the input of the buck converter. Then you now vary it via this potentiometer to give you your 3.7 volt to 4.2. That is the range of the voltage that this guy works with. Then coming down to that's for powering the controller, the GPS and the GSM. Then coming down to the display, though it's optional and tracking device display are optional. But if you choose to explore them, you can work with TFT. This is TFT, that's tinted in transistor. This guy is working fine. Or you can go with OLED, that is 0.96 inches. This is OLED. OLED 2 can work fine. With 5 volt, OLED 2 will work fine. Or you can go with LCD 2 if you choose to do. This is LCD 20 by 4. You can go with this. Then we have the smaller size, that is the 16 by 2. This is 16 by 2 LCD. So any of these guys that you choose is going to serve well as your display. Then coming down to our load, that is your bike or the system you're trying to track. You can decide to add ignition, that's off and on, to off the ignition or off the ignition and off the ignition. That's why we have the relay unit here. And for the relay, you can use just single channel relay. Since normally anytime you're trying to on, as in start your car or your bike, definitely it's just two wires you're trying to make them to come in contact with each other. So with this relay, I think you are good. So that's all about the power supply for the block diagram. This is the block diagram. This is a controller. You can power with anything from 5 to 12 volt, but I recommend 9 volt. Then we have the GPS. The voltage requirement of GPS is 5 volt. All the GPS module works fine with 5 volt. Then we have the GSM. If you are using SIM 900, then you are going to use 5 volt. But if you are using SIM 800L, you are going to be looking at 3.7 to 4.2 volt. Then the LCD, normally they are all 5 volt device. The relay too is what? Is 5 volt. So that is all with regards to the block diagram. So let's go ahead and explain the principle of operation and how the system works. Thank you very much. So now let's quickly look at how to interface the GPS and the GSM to the microcontroller. So we may decide to use your Uno or Nano. They all have the same pin configuration. So as we all know, whenever you have your GSM module, part of the terminals you are going to be seeing are RX and TX. TX means transmitter, RX means receiver. And by default, the Arduino Uno or Nano have D0 as the receiver and D1 as the transmitter. And also the communication protocol now for GSM, any device that you pick, any module that you pick, and you are seeing RSTX on it, you should know that the communication protocol is UART, that is Universal Asynchronous Receiver Transmitter. So that's it. So this is the default pin now for the Uno. So you now connect the Uno TX to your GSM RX, then the Uno RX to your GSM TX. That is the connection, aside the power connection. Then coming back to the GPS now, the GPS also have RSTX. So since by default now, Uno only have one pin dedicated for this, now we have exhausted. So we're going to use what we call my software serial in the programming to be able to configure another digital pin to serve as UART so that we can interface our GPS to the Uno. So coming here now, let's use D2, D3. So we're using D2 now as our RX, then D3 as our TX. So as usual also, the RX will come to TX of your GPS, then the TX will come to RX. So with this, you have successfully connect both the GSM and the GPS to your Uno. Now coming down to the display, you can decide to use LCD or OLED or TFT or Nokia 510 LCD or any kind of display that you choose to use. So let's assume we are using the OLED and the GSM, and the LCD rather, with the I2C interface. This is the I2C connection. And I2C meaning we are converting it to I2C, that is integrated circuit. And the default pin for I2C now, as we can all see on our Arduino Uno, is A4, A5. A4, A5. If you're using Uno or Nano, it's A4, A5. So let's take A4 as our SDA, serial data, then A5 as our SCL, that's the serial clock. And you have your LCD, you've already powered it, either LCD or OLED. You've already powered it, then you have SDA and what? And SCL. So unlike the UART USART that are going to interlace it, take RX to TX, TX to RX, here you connect it directly. That is, the SCL of your display will go to A5 for your controller, the SDA will go to A4. So with this, you have successfully connect your GSM, your GPS, and your display. So the next thing is for you to write the program. And if you want to add locking mechanism, as most people usually employ that in their project, just pick any pin of your controller, let's say D4, D2, D3, but let's say D4 here, and connect it to your relay module, to your relay. And this is your car or your bike or anything you're trying to play with. So definitely the key is going to have two terminals like this. Then this one comes to the signal. You've already powered your relay too. You have your common, normally open, normally close. So your common now will come to one of the ignition. That's the key. Then this is your normally open. Your normally open now will now go to the other terminal. So anytime this guy kicks now, the information from the common will definitely relay. It's like you are actually on, just like a key. It will definitely relay to the normally open, and your device will come on or off. So, and basically for you to be able to track it manually, it depends on how you write the code. Mostly we use this command track. So whenever you send command track to the SIM that is on the GSM module, then the system will actually understand, then reply you with the location of the vehicle or car. Basically, usually come in Google Form format where you can just click, and once you click, take you to the location, showing you the exact location where that vehicle or the car, so rather where the vehicle or the mechanism you're trying to track is. Another thing again we need to understand is that the information on the GPS are mostly saved on the EEPROM of your microcontroller. So, and if you want to use it as a data logger now, you can now add maybe SD card. You can add SD card module for saving it on the SD card with RTC. That's the real-time clock. so that you now write code that, okay, after 10 minutes, be logging in the location on the SD card. And if you like, you can still take it down with your ESP down to cloud. That is, you want to be saving it on cloud, either any IoT interface or any website that you design specifically for this. So if you have any recommendation, I will actually be willing to hear from you. Like, share, and subscribe as usual. For the Hausa version of this, as usual, you go to NAS console page. We're going to drop the Hausa version. This page is basically for the English, and for the Hausa version, you go to NAS console page for it. God bless Nigeria, and God bless you all. Boom.